Arduino for Beginners, Episode 14. Wireless Bluetooth serial communication between two Arduino boards. Now, in the last tutorial I did, we looked at wired communication. Works really good if you're not going to have the two microcontrollers too far apart. Now, if you were going longer distance, and with these we're using an HC05 and an HC06, you can go reliably about 40 feet on a wide open outdoors with perfect weather conditions. I do believe these are rated up to like 60 some feet. But look at more practical distance of about 30 to 40, which gives you a lot of room to work with. Now for the Bluetooth modules, like I said, I'm using an HC05 and an HC06. You can either use two HC05s or you can use one HC05 and one HC06. The difference between these, the HC05 can be configured as a master or a slave, where the HC06 can only be used as a slave. So in order to use the Bluetooth to communicate between the two, one of them has to be a master. But if you have two HC05s, you can configure the other to be a slave and use it as well. And I've got, here's a closer look at an HC06 and an HC05 right here. Now, to program these, the HC05s, the HC06s you have to do nothing with. Those come from the factory and slave. The HC05 also comes factory from as a slave. So the one that the board that you're gonna have the slave on doesn't need to be programmed. For the one that does need to be programmed, you're gonna have to enter the AT commands. Now, there are multiple ways to do this, and it kind of depends. There's slight variation to the HC05. I recommend, this is one I don't really use much, but the one I have down here has a little push button on there. Now, the ones with the push button are a lot easier to program, and there's more videos and information on those. These ones, it is possible to program, but it takes a little more work to do it. So I recommend the one with the push button. And like I said, there's tons of information on YouTube on how to set that one up, but try to get the one with the push button. It'll be a lot easier for you. All right, well, with that, another thing we're going to need is you're going to need some logic level converters. Now, I'm going to, first thing, somebody's going to leave a comment below. No, just use a voltage divider. You want to use a voltage divider, go ahead. These logic level converters that convert, because the Bluetooth board works on 3.3 volt logic, and the Arduino we're using 5 volt logic. These logic level converters are extremely cheap. This is a 2-channel. I got a package of 10 of them for like $3, I think it was, maybe $2.50, something. That was with free shipping. These a lot easier to use and safer than using a voltage divider. If you want to do that, go ahead. I'm not going to cover how to use a voltage divider. I recommend strongly just getting these, and you just need the 2 channels. You don't need the 4s or bigger. If you think you might need a bigger one for a project, some other project later on, get a 4-channel. You can use it. You just only be using 2 of the channels. All right. Well, with that, let's get down to how we actually hook this up. Now, I'm going to go through it maybe a little quick. So I'll let you know. You can look in the description below. And I have another video that just covers hooking the HC06 and 05s up through the logic level converter. But I will run through it again here quickly. So the first thing we do is we put our board in. And on this side we got the HC05. Now the HC05 has 2 extra pins. Those are just for programming. The HC06 you see here only has 4. And with this, we're just using the middle 4. The outer 2 on the HC05, those are for programming it. You don't have to mess with those for this. So what we're doing is the power on these boards needs to be between 3.6 volts and 6 volts. So you cannot use the 3.3 voltage that we're using with the logic level converter. You actually have to power the board, the VCC in, and you'll see that labeled on the back, the pin. That pin, connect your Arduino's 5 volt power source. Then connect your ground to your common ground, and take your RX and TX and just run 2 jumpers over to it'll either say 3A and 3B, or it'll be low A, low B, or L A, L B, low. You want the low voltage or 3 volt side. connected to the Bluetooth board. Then the side that says H or 5, A and B, that runs to the Arduino. Now when you run those through there, remember, just like wired communication, the RX goes to TX and the TX goes to RX. You want them swapped. That way they can communicate with each other. Then all we got left to do is there's 2 grounds, one on each side. Make sure to hook both those up to your common ground. Then on the 5-volt side, you'll see the, actually this is the 5-volt, the VN or 5N, that goes to your Arduino's 5 volts. And then the 3N or 3-volt N, that goes to the 3.3 on your Arduino. As you can see, I've got that run to the 3.3 volt pin. And that's all there is to it. Well, then I got my 5 volts running over the board here so I don't have to run lines to everything individually. It looks kind of complicated, but it's not. And once again, I do have another video that I go into a little more in-depth about this. Now this one hooks up the same way. The boards are identical except for the fact this one can be used as a master, and it's got 2 extra pins that you're not even using once it's been programmed. With that, we are using the same sketch we used in the last episode. I will get to that in a minute. Actually, what I'm going to do is after I demonstrate it working and stuff, I still have the footage I shot for the last video on going over the sketch. There's no point in reshooting that part. I'll just tack that on at the end here so you don't have to go over to that video to watch it. But it's the exact same sketch. All we're doing is instead of using 2 wires to connect the boards, we're using 2 Bluetooth modules, which are all individually controlled by themselves. It's just you got to send the serial communication to them, and it transmits back and forth. So, well, let me demonstrate it working here. Like I said, the last sketch, we had it hooked up with a push button on one side, an LED on the other. So we push the push button, turns the LED on, push it again, turns it off, on, off, and if we hold it down, it'll blink. Same exact sketch we had in the last one. I actually, since doing that, I left the same sketch uploaded. I haven't even plugged them in, done nothing different with it. All right, with that, I don't think there's really anything else we need to cover. This video is just about how to get it connected up and show you some basic uses of it, because as this series progresses, we are going to get into some more complicated things where we're going to start having microcontrollers communicate with each other. We also eventually start getting into using your smartphones to be able to control stuff with the Arduino and send readings back and forth and control LEDs or lights and different things like that. But that'll be a few episodes down the line yet. There's a couple other things I want to cover. Another one, communication I want to cover here pretty soon. We're going to look at the infrared, being able to communicate between 2 boards with infrared, and also we'll look at how you use the infrared with the Arduino board. Make your own universal remote for controlling TVs and stuff like that. So, all right, if you watched the last episode, you've already got the sketch. You can just go on to the next episode from here. Otherwise, if you haven't seen that one and you don't care about wired communication, you just want the wireless, the sketch I'm going to go over here is the same, so check that out. Otherwise, thanks for joining me here today. Have fun building, and I hope to see you here in the next episode. So here's the footage on the sketch. All right, I got the Arduino Ide opened up here. Now I went ahead and I already got both these typed up, make it go a little quicker. If I go through a little too fast for you, if you're trying to type this in as going along with the video, just look in the description below and you can go to the website, and both these sketches will be on there and all the information related to this project. Once again, just look in the description below, and you can copy and paste it in your Arduino Ide if you'd like, but I do recommend typing it in because that actually does help you learn this a little. It kind of burns it into your brain as you're typing it in, so I do recommend, type it in, but whatever way you want to do, I mean, just go and copy and paste if that's all you want. But all right, let's get into it here. What we're doing first, and this is the transmitter. This is the one with the push button. So what we're doing first is we're defining we're putting the push button on pin 13. So we're defining that push button 13. And again, if you want to put the button on a different digital pin, go ahead, just change the 13 to whatever pin you're putting it on. Then in the void setup, we're starting the serial, so we're doing the serial.begin, and I'm running the 9600, which is a very common baud rate. Once again, if you want to change this to a higher rate, and you want this to transmit and receive even quicker, go ahead, just make sure both boards sketches have the same baud rate. Then we're setting the pin mode, the button, and we're calling the pull-up resistors, so it'll be an input and then the pull-up, which turns the pull-up resistors on that are built into the Arduino. Then we're going down here to the void loop, and what we're doing is we're doing an if. We're doing a digital read, the button, which is the push button on 13, equals low, which means the button has been depressed. It is serial writing, serial.write. Don't use a serial.print or serial.print line. That won't work for this feature. There are circumstances where you will use that, but for this, no. You want the serial.write, and I'm just sending a value of 100. Once again, you can change this value. Just make sure on the receiver on the other end that you're detecting for, you have it so it's looking for the same number. So say you wanted to use 1 or 2 or 1000, whatever, just make sure on the other end it's looking for that. And then I got a delay. Okay, I guess I have a ½ a second delay here. And that's just to debounce the button, so when you push it, you got, you know, a little time to let go of it, and it's not just repeatedly turning that off and on. This could be changed down to a ½ second. You should be fine. If you went down to like 10 milliseconds, which would be a 10 here, you're probably going to push it. By the time you let off, it would detect it's being pushed a couple of times. And then in the program itself, we're doing a delay of 100. That's just, it's delaying the program. If it's not reading the button low, it just stops for 100 milliseconds and then goes back through and goes back through and just keeps going and going and going. And this is for stability. This delay, you could probably get away with like 10. I would put an absolute minimum of 5. Even no matter what you're sending, it adds stability, so the program, the sketch, isn't running at like Mach 10. But that's all up to you what you want to put in there. I mean, it will work with 0, but it does run a little smoother with a minimum of 10. I just chose 100. It works. All right. Well, this is all you need for the transmitter. All right. Sorry, my screen capture program glitched out there, but we got her back up. Okay, now we are taking a look at, this is the receiver side. So this would be the Arduino board that we had the LED on. So right here we're defining LED on pin 13. Once again, whatever pin you want to have it on, just change this. It's all up to you. Then we have here, we have an integer called value. We have an integer called state. Now the value is the number that we're sending from the other one. This is where that's going to be stored. And the state is just, it's storing a 1 or a 0, and it starts at 0. That's why there's no number after it. And that's just 0 means the LED was off, 1 means the LED was on, and that's how we can switch it off and on down here with our if statements. Now, then in our setup, again, we've got the serial.begin. And remember, if you change your baud rate, make sure you change it on both boards. On this one, we got the pin mode set for the LED as an output, of course. Then we're digitally writing LED low just to make sure it's off, just in case something glitches out. You actually could probably skip this and be fine. I just like to throw it on there just to make sure it doesn't accidentally is on when the program, everything loads up. So now down in the void loop, we're doing if a serial.available, which it's checking the serial port, and seeing if there is something there, which means it is greater than 0. So if it's greater than 0, means there is something there to read. Then it's going in and it's setting the val, our integer up here, to read that number, or the value that was sent, and it's being stored in val. Then next, we're checking if the value, the number that was received, equals 100, which is what we were having the transmit board send when the push button is pushed, and the state equals 0, which means the LED was off. Then it digitally writes the LED high. Then we do the state equals 1, so now that it'll know it's on. And then we're doing a delay of a quarter second, 250 milliseconds. Otherwise, else if the value equals 100 and the state equals 1, which means the LED was already turned on, then it's digitally writing the LED low, and it sets the state to 0, so that next time the button's pushed, it knows to turn it on. And then, of course, again, another quarter second delay. The delay is up to you, how long you want. I just put the delays in there. It kind of helps the program run a little smoother, and it's not running at warp speed. That's all there really is to it. On the receive end, you probably could do no delays and be fine. But my personal preference is, even no matter what, I'd put like a 5 milliseconds or 10 milliseconds. It just helps things run a little smoother. If you're not understanding why, there are other videos on YouTube about, the stability to keep the program running nice and smooth, and that's why we're using the delays. But yeah, that's all there is to this. I hope this information helped you out. If it did, hey, give me a thumbs up. I'd appreciate it big time. And also, both these sketches, the receiver, transmit, that'll all be on the website. Just look in the description below. There's a link that'll bring you right to this project's webpage. And also, the next episode we will be covering, and we'll be using the same sketch. Nothing's changed. All we're doing is, instead of wired communication, we are going to use the HC06 and an HC05. You have to have actually both. You can't use two HC06s. You can use two HC05s, because you can set, the HC05 can be slave or master, where the HC06 can only be slave. So you have to have at least one HC06 for the next tutorial, and that'll be the Bluetooth communication between the two boards. So, all right, I'm just going to wrap this up then. Please subscribe, and I hope to see you here again on episode 14, Serial Communication, Wireless, Bluetooth. So, I hope you have a great day, and remember, have fun building.